Good morning, everyone, and welcome to our inaugural Premier Pulse virtual series. My name is Shaun and I'm chair with Saskatchewan Pulse Growers Board of Directors. I farm in Kyle, Saskatchewan. I'll be your host for the meeting today. This is the first time we've offered our winter extension meetings online, and so we're really pleased to have you all here today. We wish circumstances were different, but we're making the best of it. We'll also be hosting a live Q&A session with an agronomist panel at the end of the presentations. So if you have any questions, please type them in the question box on your panel and we'll address them in the panel discussion. Lastly, I want to thank today's session sponsor. Thank you again, Schooler Canada. Today we are opening our session with some welcoming remarks from SPG's Executive Director, Carl Potts. Morning, Carl.
Good morning, Shaun. Thanks for the introduction, and thanks everybody for joining us here today. Today's session is specifically about peas, and it's our first Premier Pulse session for the year. Just want to make some comments with respect to peas to sort of set the stage for the presentations and good presentations that we have here today. Increasing the yields of established pulse crops such as peas is one of SPG's key result areas or strategic goals. On-farm yield gains come from enhancing the genetic yield potential and from reducing agronomic constraints. In order to support yield potential, we must continue to invest in furthering genetics and to undertake work to reduce the impacts of weeds and diseases. SPG is supporting these efforts for peas through a number of major strategies and investments, and I want to highlight just a few of the things that SPG is doing specifically related to peas. Next slide. SPG has recently refreshed the R&D strategy, which guides our work and investments that we make in research, and now includes a more intentional focus on the biggest issues for growers. This strategy includes the mitigation of root rots in peas and lentils. In the shorter term, we'll be focusing on getting the right genetics grown in the right places around the province and determining and communicating the best agronomic practices for Saskatchewan pulses, with an emphasis on weeds, disease, fertility, seeding rates, rotations, and harvest timing. For a couple of years now, we've been talking about how SPG's role in pulse breeding will be changing. SPG has had a long-term breeding agreement with the University of Saskatchewan for many years. SPG has invested more than $40 million into breeding and another $20 million into research supporting breeding at the CDC since 1997. SPG has released 129 pulse crop varieties royalty-free to producers over that time period, and this agreement came to an end or expired in September of 2020. SPG was interested in continuing a similar arrangement, but CDC wanted to move into a different funding model similar to what they use for other crops such as wheat, where they have multiple sources of funding. So as we look forward, we anticipate that growers will pay for access for new varieties through royalties like you do on other crops. But all the varieties that are developed under SPG's previous agreement with the CDC will remain royalty-free, and this will include the varieties that are released to seed growers this year and next year as well. So we're excited about the potential to partner with a number of private and public breeding programs to develop the best possible varieties for producers here in Saskatchewan. For us to invest, there'll have to be an expected return on investment and value sharing with growers in order for us to invest. But that doesn't mean that we won't be working with the CDC as we go forward. In fact, SPG recently announced new funding for pea breeding for 3 years at the University of Saskatchewan's Crop Development Centre in a project that was co-funded through the Agriculture Development Fund and other co-funders. This project is specifically focused on breeding peas for root rot resistance, which we know is one of the top issues and concerns for pea growers in Saskatchewan. Next slide, please. As I mentioned earlier, communicating information to growers is an important part of what we do. Good R&D is important, but we also need to get this information to growers that are looking to adopt those practices. We've shifted our communication strategy over the past couple of years to have a digital focus. This has expanded our resource library of relevant agronomic information and expanded the tools and ways in which we share that information with growers. Adopting new technologies and tools has brought information to growers and agronomists through webinars to dive deeper into technical information, and through a new podcast called Pulse of the Prairies, where you can listen to information in your vehicle, from the field, or anywhere in between. By moving to digital delivery of information, we're now able to communicate with you more frequently, at least every couple of weeks, resulting in smaller, more bite-sized doses of relevant and more timely delivery of key information. Next slide. And finally, we know that we can't just simply produce more peas. It's also essential that we develop and diversify global markets and end uses in order to keep Saskatchewan growers profitable. Peas and pea ingredients are a major focus of that national market development strategy for pulses that's being led by Pulse Canada. Some highlights of this strategy include building capacity of pea processing here in Canada and the overall increased use of peas in fractionation. Diversification of end uses for peas include working on manufacturing and innovation with pea protein and pea flour into cereal-based foods, batters and breadings, meat applications, dairy and meat alternatives, and bakery items. We're also working to increase demand for pea starch in industrial applications as well. A great example of the importance of these market development efforts is through the growth of the Chinese market for Canadian peas over time. China is currently the largest market for Canadian peas, far surpassing the volumes once shipped to India. In fact, peas to China have grown 500% over the last 10 years. Building the Chinese market was a priority for market development efforts over the past decade, and the Canadian industry worked extensively to increase interest and demand for peas and pea ingredients for use in staple foods and as a feed ingredient as well. So seeing the results of those efforts underscores the importance, I think, to long-term targeted work in market development, especially in peas in particular. So as we kick off our first Premier Pulse virtual series today, we're thankful for the opportunity to still connect with growers and agronomists virtually this year. We do look forward to connecting in person when we're able to do so again, but I'm confident that you'll gain a lot of powerful insights today through the presentations and very high quality speakers that we're bringing to you here today. So thanks again for joining, and Shaun, back over to you.
Okay, thank you very much, Carl. The first presenter, I'd like to introduce Dr. Syama Chatterton, who will be speaking on root and foliar diseases in peas. As Carl mentioned in his talk there, SPG has elevated root rot diseases to one of our top issues we're focusing on through our refreshed R&D strategy and through our future agreements with pulse breeders. Syama joined AAFC Lethbridge in July 2011 as the pulse and special crops pathologist. Her research focuses on management of root rot, root and foliar diseases of pulse crops, and molecular diagnosis and identification of soil-borne pathogens. She currently leads numerous research projects on pea root rot, white mold of dry beans, and chocolate spot of faba beans. We look forward to your presentation, Syama.
Okay, thank you, Shaun, and thank you for having me here this morning. I'm very excited to talk about my favorite topic, root rot. And I just wanted to start off the morning by showing off my Aphanomyces earrings. My husband got them for me for Christmas. I thought they're quite remarkable, and I finally get a chance to wear them. So I've got my little oospore on the back here, and then our Aphanomyces mycelia. Anyway, so I thought that was quite exciting. So I'm going to talk today about pea root rot for the most part, and then a little bit about foliar diseases. An overview of what I will be talking about. So for those that attended the webinar back, I think it was November, this will be a very similar presentation, but I've condensed it down into about 20 minutes to talk about root rots and really focusing on what we can do in 2021 to try and reduce the risk of infection. And then I will talk a little bit about bacterial blights. And I just wanted to say that most of what I'm talking about today is covered in this fact sheet put out by SPG, and I believe it's also in what the handout that is provided to you. So how can we reduce risk of infection of root rot in 2021 specifically and beyond? And at this point, I figured that everyone knows about root rot, they know about the causal agents, they know about Aphanomyces, so I'm just going to get right into the meat of the presentation without going on some of the background so I can use up all my time. And so really when we're talking about risk, the biggest risk factor is past field history. So the first thing you want to do going into 2021 is review that past field history of the fields that you're planning to plant to peas or lentils. And what it comes down to is that the more times pea or lentil have been grown in the field, the more likely you are to have high inoculum levels. Unfortunately, we don't have a magic number, so we can't say, well, if you grew peas 4 times, then you're in trouble. It really is very field specific. Some research came out of Sweden and the Netherlands quite a number of years ago, around 1993, looking at the frequency of pea or really peas in a field. And they found that some fields it took 3 occasions of a pea crop, other fields it took 5 to 6 occasions. In the Netherlands here, this is kind of a graph from an older paper, but they really looked at how many times you had legumes in 18 years. 0, 1, 2, or 3. Black here means no disease, so you can see, no legumes, you really don't have any disease. And then as you start increasing that frequency of legumes in 18 years, you see that black bar reducing and you can see that disease starts to develop. So, in general, we're looking at the fact that this is very field specific. It tends to be heavy textured, high clay or compacted fields that do worse. Having said that, there are also other factors of which we are currently unaware or trying to figure out. Some of them have to do with the behavior of oospores in these different soil types, and I will talk about that a little later in the presentation. And generally what we're seeing is that if you have a 20-year history with pea or lentil in your fields, every 4 years, that gives you about 5 to 6 times you've had pea or lentils in a field, and that's generally when we start to see troubles brewing. So when you're planning your seeding intentions for 2021, you want to first review how many times you've had pea or lentils in that field. And you also want to think back to how your pea and lentil crop did the last time in that field. And I've given an example here of 4 different fields. The first one here is a very healthy field. So if the last time you grew pea or lentils, your pea crop looked like that, then you're generally good to go to plant pea in 2021. If your fields look like the one down here, where we have kind of these bare spots, you see light yellowing spots all throughout the field, then it's best to hold off planting pea or lentil in this field because you'll likely encounter some issues in 2021. The trickier fields are one that are just starting to show these little yellowing spots. And here you can see along here that we're really getting some yellowing at the depression in the field, and that you see these yellowing along this kind of water tracks. And here's another one showing yellowing along water tracks. But generally the rest of the field looks great, and you'd probably get a really good yield from these fields. So these are the ones that you really have to think about a little more. And then the next step is then to review the environment and to also soil test those low spots. So that's what I'm talking about in the next few slides. So in the environment, then the last time peas and lentils are grown is very important because this Aphanomyces pathogen, because it requires water, we tend to see in years that had pea or lentil that were very wet years, where you may have had flooding or saturated soils. That's when this pathogen really gets going. And what you can see is that a small patch, like I showed you in those previous slides, it might not be a big deal in 1 year, but that small patch can spread to an entire field under extremely wet conditions, so that then the next time you grow peas or lentils and it's wet, you can have your entire field infected. For example, one of the fields that I work in that's near Lethbridge, where we do our field trials, in 2011, the producer noticed some small patches in the field, and actually that was a very wet year, and the field was actually flooded, I think in kind of early June. The water receded and his pea crop did okay, but he did notice some small yellow patches in that field. And then the next time he planted that field was in 2016, and then that entire field was infected. So because of that water spread, it spread from small patches to an entire field. And then we've been doing field trials in that location ever since 2016, and we can see that the the field is still infected. So when you go to plant your fields to pea or lentil in 2021, on top of reviewing how the fields did the last time it had pea or lentils, it's also important to review how wet those fields were in May and June. And so this is a good reminder to start keeping very good records of these fields, because it might be hard to remember how wet your fields were the last time you had pea or lentil. And Sherilyn put together this nice table, just kind of summarizing what the rainfall looked like in Saskatchewan over the last 12 years or so. And really, I think what pops out right away, here we see you kind of put the text for above average rainfall in red, and then years that would have below rainfall levels here in green, so you can really kind of see where they stand out. And I think what's clear is that we see that there was lots of years with above average rainfall in the past 10 years or so. Really every other year was kind of an above rainfall year, except for the past 2017 to 2019 were fairly dry, except for Northwest Saskatchewan. And I think one of the questions that was posed to me was, will we ever be able to grow pea and lentils again in Northwest Saskatchewan? And the issue is, sorry, really peas in Northwest Saskatchewan, not lentils. The issue is when you look at these rainfall patterns for Northwest Saskatchewan in the last 10 years, I think 7 out of those last 10 years had above average rainfall levels. And that's really what's driving the disease. And so it's why we see that area is so hard hit by this pathogen. And so on top of reviewing past field history, past environmental conditions, the other thing that we recommend is to soil sample prior to planting peas or lentils. And so this can be done in the spring when you're making those seeding decisions to decide whether you should put a pea or lentil in that field. And there's really 2 questions that we want to ask. The first one is if Phanomyces present, and the second one is at what levels. And that second question about levels is a little more challenging to answer right now. And so really what we're looking at is this question of presence and absence versus quantitative numbers, or how many oospores are per gram of soil. The trouble with the second question, or this idea of what are the quantitative numbers, is that the threshold for detection of the pathogen is actually very similar to the threshold for quantification. And I'm going to go through some graphs in the next couple slides to show you what I mean by that. And so if you're getting your soil tested, some labs just come back with a yes or no. And basically, if you have a yes, then that means yes, there's a risk of having Phanomyces. If you get a no, then you're like, okay, I'm talking about maybe what a no means too in the next couple slides. So yes means definite risk, no means let's think about this a little more. And those labs that provide quantification can, will maybe give you back numbers that look like this, from somewhere from 0 to 10 would be, so no to low risk, 10 to 100 oospores per gram of soil, you'd be looking at a moderate risk there, and then greater than 100, definitely high risk. And then I'll show you graphs in the next slide as to what I mean by that. So what we've done in my lab was try to kind of relate how many oospores you had per gram of soil to the disease severity here. And we did that with a whole number of different types of soil. Black, dark brown, and then those are also broken up into, a clay loam, silty, sandy loam, all the different soil textures we've looked at. And part of the issue is that every soil type or soil texture seems to return a different curve here, where we're looking at how much disease is caused by how many oospores. So I've just shown an example here of these curves for a black and a dark brown soil, but I actually have about 10 different curves for all the different kinds of soil that you can get. And so what we see here is that, from 0 up to about 10, we really don't see much disease progress. I should mention that we consider healthy, so we don't see any disease at all. 5 is basically when the plant is dead. So from 0 to 10, we really don't see any disease progress. And that's why if that's what your results came back with from your soil test, then you'd say, okay, no to very low risk. The problem is that it jumps up then very quickly. So we go from 10 up to 100. And what we can see here is this is also what the inflection point of our graph. So you can mathematically calculate what the threshold is, and it comes out onto an average about 100 oospores per gram of soil. So, you know, between 10 to 100, you're just starting to creep up to this threshold level. And then once you're over 100, you can see how that curve flattens out. And why this happens, you know, it's a very low threshold level. And why this happens is because of the Aphanomyces disease cycle. And Aphanomyces produces oospores. I think everyone's heard me talk about that before. Here's a nice picture of them in the roots, and you can see how many oospores get produced and left behind in these roots. And then one oospore, you know, doesn't cause a lot of disease, but what happens is those oospores germinate to produce hundreds to thousands of these little zoospores, these little guys that then swim and infect the roots. So we're trying to detect the low numbers of oospores that actually multiply and produce a lot of zoospores. The problem is these zoospores are quite transient in soil, so they're not a good, you can't really detect them because they're so rapid in soil. And so we're trying to detect oospores because that's what's left behind in soil. But you know, there's not a huge amount that causes disease, so we're trying to detect something that's at fairly low levels in the soil. And so when we look at soil testing, there is 3 different methods to detect Aphanomyces. The first is culturing, the second is a soil bait, and the third is a DNA extraction in qPCR. And I don't want to go over this too much because I did talk about it in the last webinar. But basically what we're focusing on for soil is a soil bait or a DNA extraction followed by a qPCR method. The soil bait is the most reliable, but it's not entirely quantitative, and it also takes a long time to do. And because of that, it can be more labor intensive, and so it might cost more to get a soil bait test. DNA extraction is very fast, it's very accurate, it's quantitative, but it's not always reliable, and the false negative rate can sometimes be high. So that's why when I said if you get back a no result, it doesn't always mean no. You maybe have to think a little more about, well, what did my field look like? I know it was yellowing. I know it was very wet. Even if the soil test is coming back as a no, you know, you might want to think a little more about that. And the reason why we sometimes get these false negatives from DNA is because of these low numbers of oospores that are required. If we were absolutely 100% able to detect oospores every time we look for them, we would have a line that looked like this. And when we start looking at different soil types, you know, from a sandy loam soil, we actually can get pretty good detection. You actually get maybe a little more at those lower levels. When we look at a silty loam soil, we can see that curve is starting to fall below this kind of perfect line. And that means that the numbers that are coming back that are being measured are actually lower than the numbers that are there. And then when we look at the clay loam soils, we can see that line has come down quite a bit from this kind of perfect line. And this would mean, you know, if you have 100 oospores, it's maybe coming back to you and saying that you have less. And this is where the issues with the false negative can occur. You know, so we want you to soil sample. And for 2021, this can be done in the spring prior to planting. Even though there's some issues with the DNA quantification and the qPCR, we do recommend it to give you an idea of that risk for that field. But like I said, beware of the false negatives and use additional factors to make your decision. So think about that field history. Think about how many times pear lentils have been in that field. Think about how wet it was the last time you grew pear lentils in that field. And if you come back with a false negative from a DNA or qPCR test, and you know you think, oh, that just doesn't seem right, I know what these other factors were, then you can consider doing a soil bait test, because those tend to give you a much more realistic results. They just take a long time. Having said that, you can actually do a soil bait test in your kitchen windowsill if you wanted to. But to maximize success of the pre-plant sampling and to try to minimize those false negatives, it's also very important where you choose your sampling spot. You look at choosing low spots, those water tracks, seepage areas, areas that are low yielding. So this is why it becomes very important to start keeping records of your field so that you know where those spots are, so that the next time you want to plant peas and lentils, say in 3 years from now after 2021, you know how your field did in 2021 to go back and sample. And then the other thing that we recommend is testing of multiple samples, or at least collecting from multiple spots, and you can put them all together as a composite sample to be tested. Then another question is this interval between successive pea or lentil crops. Oospores are very long-lived. They have a half-life of a year, so that means they decay, half of them decay every year. But if your whole field is infected, that means you can't put pea or lentils into that field for at least 6 to 8 years. And again, the exact interval time is unknown and is field specific. And there's a couple of reasons why it's field specific. The first is how many oospores did you have in your field to start with? And this was some research that was done in collaboration with Dr. Luke Baynard at Swift Current, where we went and surveyed fields and they collected soil samples and then determined how many oospores were in the soils. And basically the red dots here mean there's more than 1,000 oospores per gram of soil. Orange, I think, was more than 500 and so on. And when we looked at sort of the mean across all the fields that tested positive for Aphanomyces, the mean oospores per gram of soil were about 1,000 in peas and about 100 in lentils. So for whatever reason, a little bit lower there. And so I took that kind of number and looked at, okay, well, what's just our hypothetical oospore decay curve if we're thinking that they have a half-life of a year. So basically their concentration is being reduced by half every year. And so, if you're starting out with a field that has 1,000 oospores per gram of soil, and then you want to bring it back down to below that threshold of 100, you have to take it, here we're looking at about the 7-year mark or so. So that's why we say 6 to 7 years or 6 to 8 years. If you're starting with 100, then it might not take you, it's not going to take you as long to get below that threshold level. But so it's hard to predict for just say in general, how many years do we need of a crop interval, because it really depends on your starting oospore level. Okay, and then the other thing is when we're looking at this frequency of pea, just again showing how it's different for each location. We had one location in Lethbridge where we had, the last time it had peas was in 2016 here, and then we planted peas again in 2020, and we saw a really big reduction in disease severity. Contrast that to our field in Tabor, that's just by me in Alberta here in Lethbridge. The last time it had peas is in 2014, and we planted it in 2020, and you can see that that disease severity really didn't come down at all. So again, very field specific on the crop interval that you're going to need. Which is why the soil testing is important, because that'll give you some of that information on whether your inoculum levels have been reduced or not.
Just a reminder, Shaun, you have 5 minutes left.
Okay, thank you. So reminders for 2021, choose your fields for pea and lentil carefully, review that frequency, review past performance, review past weather, and what your field conditions were the last time you grew pea and lentils. Do a soil test, particularly from low spots, any areas where water collects, any areas where you notice you've had maybe lower yields. Consider seed treatments, especially for the low risk or patchy fields. This is just to reduce the effect of other pathogens that can interact with the Aphanomyces. And then during the crop season, it's very important to check and test your roots. And this is because shoot symptoms may not be obvious even if there is root rot. These are some plants that were grown side by side in one of our field plots, and look at how amazing these shoots look. You would never have guessed there's root rot. And then these ones you can obviously tell, but just to show you never can be certain. Again, here's some peas pretty early on that look quite healthy. We dig up the roots and you can see that root rot is setting in. And really the best time to test your field is actually when there's roots in that field to know for sure if it's Aphanomyces. So a good reminder to always check your roots. And then with lentil, the same. Sometimes you can't always see, you can get some nice green shoots. Some of them are yellowing, but then you see what those look like. And so all of this that I talked about is really summarized in this table here that is provided in that Reducing Root Rot Risk for 2021 handout, where you look at what those major influencing factors are, and that's really what I talked about today, and then what some of the other issues are and some of what the management factors are. So I'm going to switch over now in the last 3 minutes and talk very quickly about foliar diseases of field pea, particularly with an emphasis on bacterial blight. This is survey results that were provided to me by Dr. Ali Reza Akavan with the Saskatchewan Ministry of Agriculture, where they did pea surveys. And we know that Mycosphaerella blight, in 2020 was actually very high, and that's because there was so much humidity. But I'm not going to talk too much about Mycosphaerella blight because I think we all just know how to deal with it now, that it's a part of our part of growing peas. But what was interesting in 2020 was that they did see a lot of bacterial blight, particularly again in that northwest part of Saskatchewan, and that's because there was such high humidity. So I was asked to just talk briefly about bacterial blight so people know what they're dealing with. This is caused by a bacteria. The symptoms can actually be quite severe in early season. These are some pictures that I took of a field. This was in Alberta, and it was actually, I think, in 2017. And it looks quite bad, but oftentimes when you get this early season infection, the plants grow out of it and are totally fine by the end of the year, or by the end of the growing season. It is sporadic, but it has been more common in recent years. And really the reason for that is because we've seen these really wet conditions in fall during harvest, and that allows the seed to become infected, and then this infected seed gets planted, and you get bacterial blights early in the season. The issue with bacterial blight is it can often be confused with Mycosphaerella blight, and so people will spray for it, but the sprays, a fungicide spray that you use for Mycosphaerella blight won't do anything for bacterial blights. And so just some of the ways the symptoms can be distinguished. For bacterial blights, the lesions are always contained within the veins, whereas here with Mycosphaerella blight, you can see it's grown right over the vein. Usually if you hold these up to the light, you get this kind of windowing effect. The lesions are translucent. And then we also get this kind of watery bacterial ooze, and I'm going to show you that on the next slide, what that looks like. So just up close, you kind of get this white film on the lesions, and that's kind of bacterial ooze. This is kind of the watery effect that you see on the stems that you don't see with Mycosphaerella blight. It's often associated with wounds, and interestingly, pea leaf weevil might be an entry way for bacterial blight because we often see a lot of it right along the leaf margins after pea leaf weevil feeding. And then it can get quite extensive on the stems, and usually you'll see watery rot there. So just very quickly, it is seed-borne, it is also residue-borne, so having rotations of at least 3 years will help prevent it. The biggest issue is this plant injury from hail or high winds is usually what causes it. There's no seed treatments or fungicide sprays because it's bacteria, and really all you can do is try to avoid the seed lots with high infection levels, or if you knew the seeds came from issues where there was problems in the field. And again, more information there on the Saskatchewan Pulse Growers website. And I am all done. Thank you.
Perfect. Thank you very much, Syama. Okay, next up we have Tom Warkentin from the Crop Development Center. He's going to talk about commercially available pea varieties and new ones that are coming down the pipeline. It's important that we highlight these new varieties. They have high-performing traits that you might want to add to your crop system. Tom is a professor in the Crop Development Center at the University of Saskatchewan. He received his PhD in crop science from the U of S, and he is breeding field pea cultivars with an emphasis on agronomic traits, disease resistance, tolerance to abiotic stresses, and end-use quality. Welcome, Tom.
Thanks a lot, Shaun. And I'm just going to make sure, can you see my screen?
Yep, you bet.
Okay. Okay, but I can't see my screen. Oh, there we go. Okay, well, thank you. Thanks, Shaun, for the introduction, and thanks to SVG for the invitation to give a brief talk here about pea varieties. And Thanks also to Syama for the good, I didn't catch all of it, but for your nice presentation about root rots. And it's certainly great advice for all of us. And in terms of plant breeding, we also have root rot very high on our list of priorities. So on this slide, I'm just going to jump right in and summarize some details about yellow pea varieties. This is from data from Saskatchewan Crop Insurance Corporation, and these are the most widely grown of the yellow pea varieties in Saskatchewan in 2020. You see that CDC Meadow is still the most widely grown, and it has been for the last 5 or 6 years. And then there's several others that are grown on moderate amounts: Amarillo, Inca, Spectrum, Carver, Ardil, Golden, Saffron, Chrome, Abarth. When I look at the stats from the last couple of years, these 4 varieties seem to be on the up swing in terms of popularity, while the others are steady or declining. When I look at the data from Varieties of Grain Crops, which is the booklet that is available to everyone now, it's updated every year and released around this time of the year. What I've done is I've included the yellow pea varieties that are in the graph at the top and added a few extras. So you see the varieties here, the number of years in which they've been tested in Saskatchewan, the yield of those varieties in the south, north of the province, take the average of those 2 numbers. So I've kind of ranked them based on this column for the mean yield. And then some other features that are more or less important depending what you think. Maturity, either medium or early. Lodging, 1 to 9. So 1 is it's standing up like this arrow, 9 is it's horizontal. And you see the range of numbers for lodging are from 3 till 4.5, and you might think that's a fairly narrow range, and it is relatively narrow, but there is a difference between a 3 and a 4.5. And if we turn the clock back 10 or 15 years, these numbers instead of 3 or 4 would be probably between 4 and 6 or 7. Seed coat breakage, either fair or good, and there really is a difference between fair and good, and generally you want good for sturdy seeds that are going to be reliable for germination. And then the protein concentration of the seeds as a plus or minus of CDC Amarillo, which is here kind of in the middle of the table in yellow. It's the yield check at 100 for each zone, and it's at 23 in terms of protein in the seeds. So some are a little more, some are a little less. And then the pedigreed seed status. So F meaning foundation, R registered, C certified. So maybe just a few points that I'd like to make. In my own plant breeding mind, if I put something in bold, it means I like it. If I put something in italics, well, I don't really like it as well. So you can look at many of these features when you're thinking about a variety that you might want to pick. And I want to highlight a bit here on Spectrum, CDC Spectrum, which is now available at the certified seed level. Good yield, good for lodging, good resistance to breakage, and a little extra protein compared to the check. So that's one you might want to keep an eye on. This table is the same as the one on this page, except I've added 2 varieties at the top here in orange. These are 2 varieties that are being released right now as breeder seed by Saskatchewan pulse growers. They're coming from our program. I got them at the top because they are higher yielding than anything else in the table. You see them at 107 and 109 on average, medium maturity, pretty good for lodging, durable seed coats. This one's a little higher than Amarillo in protein. This one's a tiny bit less. So I'm giving you this slide just as a heads up because it'll be something. These are varieties that are coming. Because they're at breeder seed level, we usually think of probably 3 years until you would see them at certified. Green peas are not grown as much as yellow. Usually there's a premium for greens. Currently, I don't think there is, just supply and demand. But here are the varieties that are most grown in the green group based on the crop insurance data. Actually, these 4 were increasing to some extent in 2020 and the other 2 declining. I'm thinking that forest will creep its way higher in terms of popularity here mainly because it's a very high yielder compared to the others. These are yields as compared to the yellow check Amarillo, so it's as high as Amarillo as in terms of yield. Maturity, lodging, seed coat breakage, bleaching. So with green peas, you really have to keep an eye on bleaching because it's really the foundation of quality. Bleaching means under certain conditions, usually high light intensity combined with moisture near maturity, you can get the green color fading or actually moving towards yellow. And I've got them rated all as good, and so that might be a little bit misleading. They are good in comparison to the big picture, but within that, there are some slight differences, and probably Razor, Limerick, and Striker are a little bit better than Greenwater and Forest for bleaching. So keep that in mind as you make your decisions. And this, I just want to point out here about protein, Limerick at almost 3% more than Amarillo. Green peas are typically not used by the fractionation industry. They're typically using yellow because they want to avoid having green pigment in the protein. But nevertheless, we're using this variety in crossing to try to bring the higher protein levels into yellow. We're using other strategies as well, but that's one kind of obvious one.
Just a reminder, Tom, we've got 2 minutes left.
Yep, I'm about to wrap up.
Wonderful.
Second last slide. One new green pea variety that we plan to release in a year from now, and I'm just showing its features here. Similar yield to Forest, so good yield. One kind of interesting feature, it's one of the best ones we've seen in our trials over the last couple of years for lodging, so it stands up very well, so easy to harvest. Keep an eye for that. You might want to know how does it differ from Forest, because not really differing in yield, but the seeds are a little bit rounder, a little less bleaching, but a little bit more dimpling on average, so that I don't really like that, but also a little bit better for Mycosphaerella. So you're going to have to weigh pros and cons. So I'll just wrap up with that and acknowledge funding from Sask Pulse Growers, Ministry of Agriculture, Western Grains, and several other groups over the years, and I work with a lot of good people to conduct this kind of work. So I'll wrap it up with that and wish everybody all the best for the coming season.
Thank you very much, Tom. Some pretty exciting varieties looks like coming out soon. Next, I would like to welcome Dr. Jeff Schoenau from the University of Saskatchewan. He's here to talk about the best way to manage fertility in your pea crop to maximize crop yields. Jeff is a professor of soil fertility and professional agrologist. He holds the Saskatchewan Ministry of Agriculture Soil Nutrient Management Chair in the College of Agriculture and Bioresources and is a fellow of the Agricultural Institute of Canada. Jeff has been instrumental in developing and confirming recommendations for fertility of most crops and of course with pulses as well. Welcome, Jeff.
Great, thanks a lot. I'm really happy to be here and participate in the virtual Pulse Tour this year and take a quick swing through fertility management of peas. And what I'm going to do is I'm going to talk about macronutrients and I'm going to talk about micronutrients, folks. And when we think about macronutrients first, of course, the first element that comes to mind is nitrogen. And it all starts there, right on those roots and the nodules that contain the rhizobium that are responsible for the biological fixation from the atmosphere that can supply an appreciable amount of the nitrogen that pea crop needs. And if we've used a commercial inoculant, that nodule will contain superior strains of those rhizobium that can fix nitrogen for that legume crop and also contribute to the nitrogen nutrition of the following crop. So legumes are really an important part of crop rotation for that reason. That biological fixation of atmospheric nitrogen. So how much nitrogen is derived from the air and converted into plant nitrogen by that legume crop, by peas? Like a lot of things, what you come up with as a number depends on how you measure it, but any way you slice it, folks, it amounts to a pretty significant contribution. On average, we can think as simply about 3/4 of the nitrogen in a legume like pea comes from the atmosphere via biological fixation in that nodule. And that's a pretty significant economic contribution. And when we look at those nodules on the roots and we cut them open and we see that nice red color there, that tells us that that nodule is actively fixing nitrogen. How much is fixed in Western Canada? Well, the forage legumes like alfalfa do tend to be at the top of the heap, but not too far behind. We have the pulse crops. Faba bean is one of the best fixers, but not too far behind is peas, with amounts fixed reported in the literature ranging anywhere from about 50 to upwards of 150 pounds of N per acre, occasionally even more under very good conditions. How much you get depends on the inoculation, the nodulation. Ideally, we want to be to ensure that we have a superior strain there to be using a commercial rhizobium inoculant. Environmental conditions are important. Anything that negatively affects growth, folks, is going to have a negative effect on the amount of nitrogen derived from biological fixation. Also, the soil available nitrogen. As you could see in that earlier photo there, in the pea roots that had 200 pounds of nitrogen per acre added, there were no nodules on that root. And indeed, to get the maximum proportion of nitrogen in that pea plant derived from biological fixation, we want to be growing those peas on soils that are low in available nitrogen. Availability of other nutrients is also important, however. Nutrients like phosphorus. Phosphorus is the energy currency of life. Biological nitrogen fixation is very energy dependent, so we need to be paying attention to phosphorus fertility as well. When we calculate and do a balance, oftentimes the amount of nitrogen that is derived from fixation can approach that is removed in harvest, sometimes even exceed it. And so that's a real benefit, because that nitrogen that's removed in that harvest, folks, comes from the air instead of from soil or fertilizer, as is the case with a non-legume. How much? Well, for peas in some of our work, we've typically observed somewhere around 3.5 to 4 pounds of nitrogen in the above ground material per bushel of grain yield. So you can work out, based on your yield, how much nitrogen then is contained in total in that above ground material. About 3/4 of that comes from fixation, and roughly about the same amount is removed in the grain that's taken off the field in harvest. What about phosphorus? Well, as I said, biological fixation is a pretty energy dependent process. And for phosphorus, unlike nitrogen, all of that phosphorus has to come from soil and fertilizer. Unfortunately, there's no such thing as biological phosphorus fixation. In terms of removal in pea, field pea has in the above ground material, the grain and straw, about 0.8 to 1 pound of P2O5 equivalent P per bushel of grain per acre. So again, you can take your yield and calculate roughly how much phosphorus you got in that above ground material. And folks, about 75%, about 3/4 of that phosphorus, similar to nitrogen, about 3/4 of the phosphorus in that mature crop is in the seed, which is removed in harvest. Fortunately, legumes have pretty darn good roots, and they develop strong mycorrhizal relationships, and that is they have the infection of their roots with this beneficial fungi, AM fungi, in which the hyphae effectively act to extend the root surface area, the rooting system, and that makes them really good scavengers of phosphorus, as well as potassium, sulfur, and micronutrients from the soil. So legume crops can often, as I say, they're mobilize and access phosphorus that's already present in the soil better than a lot of other crops can. And this comes by virtue of these beneficial association with the AM fungi. They're highly mycorrhizal crop, but also they can acidify the root zone and solubilize these calcium phosphates that are common fertilizer reaction products in prairie soils, especially in the higher pH soils. And I think that explains why we often find that, pulses are sometimes not particularly responsive to phosphorus fertilizer management. And that's because they're pretty good scavengers of that phosphorus from the soil. And that's not to say that peas will not respond to phosphorus fertilization. They will in phosphorus deficient soils. And indeed, like our other annual crops we grow here on the prairies, pulse crops need and they take up that phosphorus early on in their growth cycle. This is some data that I was involved in collecting. It's fairly old now. This was back in the late 1990s. But the shape of the curves for our modern varieties will still be the same, folks. And it really shows that the maximum accumulation rate of phosphorus, and in this case, it was upwards of 0.2 to 0.5 kilograms of phosphorus per hectare per day, occurred at the branching stage. And that's the time when this curve, the slope of this curve is the steepest. And that's pretty early on in the growth cycle. So just like other annual crops, early access to available phosphorus by peas is important. And not only peas, as shown here, but also lentils as well. In another more recent study that we did, we put phosphorus in the seed row for peas, and then we looked at the phosphorus in that seed row and its depletion over time, 7 days, 28 days, and 56 days after seeding peas. And in all of the treatments here where we had the monoammonium phosphate placed in the seed row here, we can see the amount of phosphorus in that seed row at day 7, and then a large decrease from day 7 to day 28 as a result of a lot of uptake of phosphorus by those pea roots, and then further decrease to day 56. So again, those peas take up a lot of that phosphorus early on. So we need to make sure that we have adequate phosphorus nutrition early on. And so to that end, pea crops certainly can respond to starter phosphorus fertilizer on soils that have low available phosphorus supply. Now, you look back in the literature at some of the early work that was done, 15 to 20 kilograms of P2O5 per hectare. And we talk about kilograms per hectare, that's pretty close to pounds per acre. Kilograms per hectare is a little bit higher. And that amount of phosphorus was reported to benefit early growth and sometimes yield of peas. And seems like when we go out and we have a look at all of those trials, it seems like the greatest likelihood of response comes when we have soils with low available phosphorus supply, also soils that are cold, and those cold temperatures tend to restrict that early root growth, so that having that phosphorus where the seedlings of that, where the roots of that germinating seedling can access it early on become particularly important when early root growth is inhibited by cold conditions, maybe too wet, too dry. Also, those kinds of conditions will reduce the ability of the phosphorus to move to that root by diffusion. And also when roots are challenged by disease. Again, if there's some disease factors inhibiting root growth, again, having that phosphorus placed in position where those roots can access it becomes particularly important. And also when it comes to the ability of the crop to fend off disease, a well-nourished crop is a tough crop with a good ability to fend off disease. And so there are studies have shown that phosphorus fertilization can help that crop fend off root diseases. And also when the frequency of non-mycorrhizal crops, brassicate crops like canola or mustard in the rotation is high. To that end, your soil phosphorus availability assessment tools out there are very useful indeed in predicting the potential for a response to phosphorus fertilization with your peas. When we talk about starter phosphorus, we think about putting phosphorus in the seed row. We do recognize that pulse crops have different tolerances to seed-placed fertilizer feed. And in fact, peas tend to be the most sensitive to seed row-placed fertilizer, as shown there in our provincial guidelines. Whereas faba beans, we find actually are quite tolerant to phosphorus placed in the seed row. One of the things we can see is that the crop removal of phosphorus in the pea harvest, for example, a crop removal of 40 pounds of P2O5 per acre from a good pea crop, that exceeds the safe rates that you can put down in the seed row. So if you're looking at attempting to replace the phosphorus that's going to be removed in your pea harvest, you're typically looking at a split application, maybe where you've got some phosphorus there in the seed row and the rest of it in a separate band. looking at the sensitivity of peas to seed row placed fertilizer, phosphorus. This was some work that we did a few years back, showing here that once we get up above about 10 or 20 kilograms of P2O5 per hectare with the pea, we see significant reductions in the emergence. And then when we throw some potash in there as well, potash has quite a high salt index, and there we start to see very early on significant reductions in emergence. So we do need to pay attention to how much fertilizer we're putting in the seed row with peas, because they do tend to be rather sensitive to the salt effect of that fertilizer. And there's always a debate, I think, starter or no starter fertilizer. Small amounts of starter may be beneficial, but as I pointed out, injury issues can arise when we go to higher rates of seed-placed nitrogen along with phosphorus and sulfur. And really, I think we want to get those high rates out of that seed row, folks, into a separate side or a mid-row band. Some recent work that was done by one of my master's students, Harshini Dona, took a look at tolerance and response of pulse crops to seed-placed fertilizer blends and composite products that contained nitrogen, phosphorus, and sulfur. And in this work, it was done under controlled environment conditions, so we could very carefully control the conditions. So this was done in the U of S growth chamber facilities. We had 6 different crops, including peas, and we had 4 rates, and the rates that we used were applied on the basis of nitrogen. So 0, 10, 20, and 30 kilograms of nitrogen per hectare. We used a nitrogen, phosphorus, sulfur deficient brown turnipsem, typical kind of soil you'd find in southern Saskatchewan, and 7 different fertilizer products or blends that were used as starters placed right in the seed row. So we had monoammonium phosphate, a blend of monoammonium phosphate and urea, a blend of monoammonium phosphate and ammonium sulfate, and then we had different combination products out there that are available and used by growers out there in our evaluation as well. So one of the things that I do want to point out is that when you have your application rate set out on the basis of kilograms of nitrogen per hectare, those very low nitrogen analysis products like monoammonium phosphate, you end up adding a lot of product per hectare. And as you can see, a lot of phosphorus added in the seed row, more than our maximum safe allowable amounts here recommended in Saskatchewan. And so we would expect this applied on an N basis, even at that rate, with that amount of P and that amount of product, to produce some injury, and indeed it did. And for other ones, you can see different nitrogen amounts in here and different amounts of product added and different amounts of phosphorus added when we apply that 10 kilograms of N per hectare rate of actual N with our different fertilizer products in the seed row. So what did we find? And this is data here that was obtained for P, for emergence effects and biomass effects. Our control, we got 64% emergence, so it wasn't a real great seed lot that we had there. But I do draw your attention to the fact that all of those different blends and products that we evaluated there really wasn't a significant reduction in emergence compared to the control at that rate of N applied with those products. But with the monoammonium phosphate, reflecting its low N analysis and a pretty high rate of product that needed to be applied to give 10 kilograms of N per hectare, we did see a significant reduction. And furthermore, above that, at 20 kilograms of N per hectare for those, all of those products typically resulted, and blends typically resulted in a significant reduction in emergence. What did we see for a 30-day plant biomass response? Well, we didn't see a whole lot of significant increases in the 30-day plant biomass compared to our control treatment. Now, mind you, this was under conditions of actually fairly warm temperatures, so we might have seen maybe more benefit if the soil was cooler. But overall, we conclude, the emergence was sensitive to rates greater than 10 kilograms per hectare, and we really didn't see a lot of biomass response in that case. So that's macros. I want to move on in the time that I have remaining to talk a little bit about micronutrients. Deficiencies of micronutrients, we do need to be aware they can arise, but often, folks, they tend to be isolated, patchy, dependent on soil and environmental conditions. And there's some rather complex interactions among these factors that really make diagnosis and reliable prediction of response to micronutrient fertilization just inherently challenging and difficult. And when it comes to peas, zinc and copper would be the elements of micronutrient elements of greatest interest for those pulse crops, and always important in determining if indeed a micronutrient limitation does exist out there. Where do you look? So you really need to know where to look, folks. And the kinds of soil conditions that contribute to micronutrient deficiencies, one is the texture. If the soil is sandy, that indicates both a low content of minerals capable of releasing microbes like copper and zinc, and also a low ability to hold onto those micronutrients in the soil. pH is important. Calcareous soils of high lime content, high pH, will fix micronutrients like copper and zinc into insoluble forms. Also very low or very high organic matter content. For example, peaty soils, soils that have large amounts of organic matter, can sometimes suffer from deficiency in copper, zinc, and even manganese, because there really isn't a lot of minerals in those organic soils that can release those types of micronutrient metals. Nutrient imbalances are something to think about as well. It's been well documented that where we have very high soil available phosphorus, that can interfere with zinc uptake and copper uptake. And the addition of large amounts of phosphorus fertilizer to a soil that's marginally deficient in zinc can in fact induce a zinc deficiency. And we have observed, and more recently in some of our trials, where indeed that where you are applying high soil phosphorus, under those circumstances, we did see a response to zinc fertilization of the peas as well. And this was on eroded knolls that were high pH, calcareous, sandy kind of conditions where you would expect to see that low availability of zinc to begin with. As well, addition of copper and zinc, go the other way, can also reduce plant growth on pea deficient soils. So if you don't have that appropriate balance of nutrients, macros and micros, you may not be getting the best response out of your fertilizer that you're applying. Sandy grade peaty soils do tend to have the greatest frequency of micronutrient deficiencies. They do tend to occur in patches, localized areas within a field, for example, those eroded knolls, sand or gravel lenses. And what that means is that when you're out there looking for them, you need to be employing a kind of smart or directed sampling strategy to obtain your soil and plant samples to be able to detect and account for it and remediate it. And it may involve the simplest form of precision fertilization, simply applying that micronutrient to those areas of the field like the eroded knolls where it's identified as being deficient, and not applying to the other parts of the field where it is sufficient. How much micronutrient is taken up? This is some data from some other work that we did with micronutrients, copper and zinc, with soybean, pea, and lentil. And this was one of our sites at Rostern. And we call them micronutrients for a reason, because you can see there the copper and the zinc uptake is pretty low, 0.04, 0.5, 0.6, 0.1 kilograms per hectare compared to the macronutrients, but nonetheless essential. And in this particular study, we had the highest copper and zinc uptake from the pea. And that was really explained by, at that Rostern, having a very high pea yield. I think it was around 70 bushels per acre or more. And so as a consequence of that high pea yield, a lot of copper and zinc was taken up, particularly in the grain of that crop.
Just giving your 5-minute warning, Jeff.
Great, thank you. We've done some other work looking at micronutrient elements in rotation. We're Dr. Ryan Hang's working with me, looking at copper, zinc, and boron in a wheat, pea, canola rotation. And this work was done in the glass house, and we went out and we collected soils from all across Western Canada, some of which were suspected to be, based on their properties, to be potentially deficient in micronutrient elements. So we got these soils collected, we brought them back, we processed them, and we have a lot of soils there, and we looked at the response of the crops to the addition of the micronutrient elements. And this shows here the response of wheat to copper fertilization. We got in a range of those soils where we suspected deficiency based on assessment of availability, extractable amounts, and also PRS supply rates. And we got a response to copper fertilization of the wheat, as we can see there, both foliar and soil applied. I think we might have seen a little bit of toxicity, a little bit too high a rate of banded chelated form here that we had in our experiments. But when it comes to peas, I think the interesting thing is we grew peas on that same soil, and we also added zinc to some of those soils, and we maybe got a little bit of response of the peas to the zinc compared to our unfertilized control, although not statistically significant. But we did see a response of the pea yield to residual copper that had been applied the year before to the wheat. And this was a little bit unexpected, but nonetheless interesting, that positive significant response to copper fertilizer applied the year before to wheat in the pea. Not sure if it was a fungicidal or a nutritional effect, but it may be fungicidal because there have been studies that have been showing that soil applied copper can help to reduce the incidence of certain root rots. We did see a trend of the pea yield responding positively to soil and foliar zinc, but oftentimes not statistically significant. An example of that, some work that we did, in this case with a soil from southwestern Saskatchewan, a heavy clay soil, a scepter soil, where we saw a response of wheat to copper fertilization, despite the fact that the extractable copper was quite high. We expected to see a response of the pea to zinc. We saw a trend again where compared to the control, we got higher yield, but it wasn't statistically significant at the 5% level. One of the things we have observed in our work with zinc application to peas is an increase in the grain zinc concentration. Why is that important? Well, when it comes to marketability of pulses like peas in the places that we have traditionally sold, like Southeast Asia, for example, zinc deficiency exists in some cases fairly widespread in the human population. And so our peas, our pulse crops, have more desirability if they have a higher content of these micronutrients, which are also important in human nutrition, as well as in nutrition of the plant. So I guess, folks, some final points to wrap up. I think for this year's crop, the diagnostic tools that are available, your soil, your tissue, your imagery, are a good approach for determining that pea crop nutrient needs. Over several cycles of the rotation containing pea, we do need to be thinking about nutrient removal and replenish the overall nutrient balance if we're looking at aiming and maintaining, or perhaps even building our phosphorus or potassium fertility over the long run. From the nitrogen standpoint, we want to capitalize on that nitrogen fixation input that helps balance off that crop removal. That means inoculating, growing soils, growing the peas on soils that are low in available N. There's little or no nitrogen fertilizer typically needed, and we want to keep it out of the seed row to avoid damage issues. The peas we find are good scavengers, but they will deplete soil reserves over time, especially if we've got high grain yields. So again, looking down the road towards maintaining that fertility, we need to be thinking about those nutrient balances. In the short term as well, paying attention to safe seed place rates. Put the excess in a separate band to avoid injury. We don't want to push those seed placed rates, especially we may get burned in under conditions of dry surface soil, sandy textured soils. We want to be making sure that we're not compromising our plant populations too much. And deficiencies of micronutrients, folks, really don't seem to be a major limitation in many cases, but I think zinc and copper merit attention for peas when the soil environmental and crop rotation conditions are conducive to reduce supply. So with that, I'd like to thank all the folks that have contributed over the years, students and staff, also the CDC Pulse crew and Drs. Warkentin and Vandenberg, who've been great collaborators, and all of the funders. So I will stop there, and thank you very much for the opportunity to share some thoughts this morning.
Okay, thank you as always, Jeff, for sharing your latest research on soil fertility. We know weed management in pulses is critical for the health and overall productivity of your crop. Next on the agenda is weed management in peas, and we are happy to have Dr. Shaun Sharpe with us, sharing some of his research into weed management with pulse crops. Shaun is a research scientist with Agriculture and Agri-Food Canada, focusing in weed science. His research focus involves herbicides, weed ecology, precision agriculture, and integrated weed management. Thanks for joining us, Shaun.
Thank you for having me, Shaun. Can you see my presentation on the screen?
Yep, you bet.
Excellent. All right, so I'll just dive right in here. Oops. So as an overview of what I'll be covering today, I'll first talk about the soil seed bank, some physical control strategies, some expectations on using soil residual herbicides, options and insights from organic research, and then I'll end with an observation from a longer-term rotation study. So I want to begin by talking about the soil seed bank, as it's a fairly persistent source of weed infestations. By the soil seed bank, I am referring to the natural storage of weed seeds and other propagules, including tubers or rhizomes on perennials, which is often dormant, and they're found within the soils of our farm systems. So I wanted to start on a historical perspective. This graph is from an 18-year rotation study conducted at Saskatchewan. I focused on two of the relevant treatments for pea production. The D panel is for organic production, and the E panel is for a no-till with reduced inputs. Both panels are for diversified annual grains, which included peas in the crop rotation, and reduced inputs refers to using weed thresholds to help make decisions about applying herbicides depending on the density of the weeds. The y-axis is weed density in plants per meter squared that has been transformed into a logarithmic scale, so it would actually be more inclined if it wasn't. And the x-axis is in time over an 18-year period. And in both the organic and reduced input systems, using a diversified annual grains, it is shown that the number of weeds has increased over time. And this is over an 18-year period. So what this tells me is that there's an increased number of weeds that are emerging from the soil seed bank. And this is concerning for two reasons. So the first reason is that it represents a higher risk for herbicide resistance. Resistance risk is accumulated with every weed that is killed by a mode of action or a group. For example, if you're spraying Roundup pre-seeding, every plant has a chance to survive, even if it's a low risk. Risk is accumulated with every plant killed with that mode of action. So that's why we use groups on the labels, and it's why rotating modes of action is so important, as you are effectively resetting the risk counter on the new mode of action. So while that is effective, if we can reduce the soil seed bank, it would mean that we have to kill less weeds with that mode of action and pull down that risk as well. The second reason that the increased soil seed bank is concerning is that it means that we have increased populations over time, which means we have to spray more and more, and we're not getting down past economic levels. I have put on the screen an example threshold for wild and wheat, which is taken from the Guide to Crop Protection, which is put out by the Saskatchewan Ministry of Agriculture, and the thresholds are an excellent way to preventing loss of yield early season, but as far as scope goes, it doesn't take it much past that. So if there are later emerging weeds, it may not have an impact on crop yield, but they will be able to go back into the system and keep our levels static or increasing on the number of weeds that we have to kill. So what I'm advocating today is that we need to take weed control considerations a step further past spray thresholds towards reducing the seed return to the soil seed bank. These considerations are species specific, and they are informed by the nature of our targets to promote the longevity of our available herbicides. If the soil seed bank can be reduced, eventually our need to spray will also be reduced and lower input costs. The soil seed bank is the source of a lot of persistent weed issues as that weed seed builds up over time. So first we'll talk about some ways to control weeds after they have merged and perhaps we have lost control of them. So they might be going to seed, for example. And I want to start by highlighting the Heritage seed destructor. This is work conducted by Dr. Tideman, who is currently at AFC in Alberta. And the Heritage seed destructor is a cage mill pulled behind a combine, or it may be installed in the back of the combine now. And chaff is brought into the cage mill from the combine, where weed seeds are ground to a fine material, and then it's deposited back into the field. So this is effective on weeds that still have their seed on them and have not gone back into the soil. So the first panel demonstrates the effectiveness of this technology on problematic weed species on the prairies. The y-axis is control, and please note it starts at 95%, while the x-axis is various problematic species, particularly resistant species such as kochia, green foxtail, and wild oat. And as you can see, they found that they're getting over 97% control of all of these seeds. In the second panel here, we have the effect of various types of chaff. Again, the y-axis is control and the x-axis is the type of chaff. And the Heritage seed destructor works quite well at pulverizing weed seeds and pea chaff. So a second option for preventing weed seed from returning to the soil is through mowing. This strategy is going to work best on the edges of the field where the crop may be less competitive and weeds are likely more abundant, as well as around sloughs, tree lines, or windbreaks. This is going to be more effective on patchy species, including kochia and foxtail barley, which are in the image here. And I would advocate an earlier control strategy. So if you wait until it's post-harvest, it's probably too late. It may act to contain the patch, but it's not going to prevent the plants from producing seed. So next, I'm going to move on to talking about herbicides applied to the soil. I'm going to be reviewing two modes of action, group 3 and group 14. And with both of these groups, environmental factors can influence crop safety, particularly because it's going to affect how the crop is emerging from the ground. So if the crop is stressed because it's cool and wet, or if the soils are poorly drained, or if it's salty in the soils, or if the soils have been flooded, you may see increased injury across both of these groups. So I'm going to start with group 3, which are mitotic inhibitors. I'm going to be using ethylfluralin, which is trade name EDGE, as the example chemistry. So these are effective at preventing weed seeds from emerging because it's stopping them at a cellular level. Group 3 chemistry is not very mobile in the soil, and it's creating a zone of impact in which we plant below in order to achieve kill on the weeds that are above it. Ethylfluralin is a granular herbicide, which is quite different from a lot of the other herbicides that are available in liquid formulations. It also does require harrowing to ensure contact with the soil, particularly in chaff or standing stubble. And as I mentioned, it does create a zone of impact, about 2.5 centimeters in the soil and direct seeding systems. Most notably, and quite important here on the prairies, it doesn't need water for activation. So if we're having a really dry year, the chance of environmentals impacting this as far as a lack of water will be minimal compared to other chemistry. It's still recommended to use a pre-burn down application of glyphosate to control escapes. This is particularly important for wild oat since it's a large seeded annual which can either emerge from below the treated area. Ethylfluralin can be applied up to 10 days prior to seeding in the spring. With the fall applications, on the label it states October 1st until the soil freezes. With ethylfluralin, carryover can occur if there's a limited amount of moisture in the previous season. And of special note, if it's used 2 cycles in a row and then you plant wheat, it can be injury in that wheat. So once every 2 years is a better use application, particularly if you have wheat in that rotation. Ethylfluralin does have an interesting spectra of weeds that it controls according to the label, which includes our foxtails. I'll just note that trifluralin, resistant foxtails do exist and may be problematic, and it won't control them, but it does control a lot of other HR weeds. And I asked about to see some data on wild oat from Gowan, and they had supplied this table or graph, and as you can see, it gets about 75% control of wild oat in their field studies. So you want to rely on good cultural techniques to get canopy closure to control the weeds that are going to be emerging afterwards. Next, I'm going to move into group 14, which are PPO inhibitors or protox inhibitors. This group does have a wide array of use patterns, and today I'll be focused on those applied to the soil pre-emergence, particularly flumioxazin and sulfentrazone, which are trade names Volterra and Authority. And you can find tank mixes with pyrosulfone, including Fierce or authority is supreme. So I'll use flumioxazin as the example of chemistry. Residual control is dependent on rate, temperature, and rainfall. Higher rainfall and temperatures can decrease the amount of control temporally into the season. Moisture is necessary for activation, and they recommend about 0.5 to 1 centimeter. Limited rainfall can reduce efficacy, and weeds may emerge, and you may not get control of those weeds after you do get rainfall. This chemistry should not be incorporated mechanically, and the window for applying is pre-planting to 3 days post-planting, prior to when the peas emerge. So with group 14, they both do have an interesting spectrum of weeds, and they will be very useful in controlling HR weeds. And using a tank mix with pyroxasulfone will increase the spectrum of weeds that you are controlling, including getting some activity on wild oat. So briefly about authority, I just want to point out in particular that it needs a little bit more rain or irrigation to activate, but it does tolerate some incorporation if moisture is not coming. So it's a bit of a different option than flumioxazin. So next I want to move into some organic methods. I'm going to be mostly focused on cultural options. So in an integrated study looking at physical control using a rod weeder and changing planting dates, the authors found that delayed emergence until after the weeds came up, and 2 passes with a rod weeder prior to crop emergence does provide decent control. And this is akin to using a stale seedbed technique, but instead of using a herbicide, they had used the rod weeder, which went through and pulled the weeds to the surface to let them dry out and bake in the sun. P genetics is important. In a study in Italy, they had found that yield was strongly associated with weed densities, and that taller plants and larger seeds were important factors to pea competitiveness. With seeding rates, they are an excellent method to encourage a more competitive crop. This is a study from Bayard et al. In 2009 that looked at how increasing seeding rates for organic field peas impacted weed biomass. On the y-axis is the biomass in kilograms per hectare, while in the x-axis is the seeding rate, and the black boxes are for the weeds and the white boxes are for the crop. And the authors found that the optimal application rate is about 200 seeds per meter squared, which equivalent to about 120 plants per meter squared. So this is up from the estimates for conventional production, which were about 80 plants per meter squared.
Just a reminder,
So
Shaun,
I
we
wanted,
have 5 minutes left.
Thank you. I just want to come back to this slide and end with this. So with this 18-year long-term study, they had found that weed infestations, and particularly the number of weeds that are emerging out of that soil, were increasing over time. And this is problematic because it's putting a lot of pressure on our herbicides that are used early in the season. And if that pressure keeps up, it will break and we will continue to lose herbicides. So it's important to try to get those numbers down, as well as to rotate modes of action to take the pressure off a single group. And so it all starts by using pre-emergence herbicides, particularly because it's a different mode of action and it's different on how it kills the plants. That can be complemented with cultural techniques, including changing when you seed to allow weeds to emerge and then kill them, or to use high rates of seed into the system to encourage a strong and competitive crop, and to allow canopy closure to keep weeds from escaping and going to seed later in the season to put that weed seed back into the system and keep pressure on our herbicides. And if you do get weeds escaping, and particularly on the edges with kochia, it's good to go in and control them earlier in the season. If you have to use a line trimmer or another type of mowing, just to keep it from going to seed and keeping that patch stable. So the overall goal will be to have the populations either static or decreasing over time. All right, and I will end there. Thank you.
Perfect. Thank you, Shaun. Thanks for sharing all the ways we can mitigate weeds and pulse crops. Okay, so now we'd like to shift things to some live Q&A featuring an agronomist panel. Just a reminder, if you have any questions, please type them into the question box on your dashboard and we'll add them to the panel discussion. On today's panel, I'm pleased to introduce Ivan Isgajan of GMAC and Scott Anderson of Nutrien, as well as our presenters from today. Thank you all for joining us today. Now, Sherilyn, I think, was monitoring the questions. Do we have any now, Sherilyn?
You bet we do. We have tons of questions, so this is great. Thanks, everyone, for providing the questions for today. I've been tracking them as they've come in and did send some of them as a heads up to some of the speakers just so they have a bit of a chance to prepare a little bit. And I think to start off with, I'm going to focus on some questions for our agronomists. We really appreciate them being on the panel here. And so I'm going to put Scott, I guess, on the hot spot and talk about some of the questions that pertain to Aphanomyces and as an agronomist, kind of how you're approaching them. So the first question I have is, what have you seen that is helping to reduce the risk of root rots or to protect yield loss in field situations? You are in a hot spot there, and I know you've seen a lot of root rots. And you know, from an agronomist perspective, what are you seeing that is either working or recommendations that you're feeling is helping guys to mitigate that risk?
Yeah, a little bit of a hot spot out here for sure. Probably since the early 10s, 12s, 11s, somewhere in there. But anyways, yes, something that's consistently working is lack of a 3-inch rain really helps. Really, it's coming down a lot to climate. I mean, rotation obviously has helped. I've seen growers that are into that 4-year rotation pretty regularly, and you know, it goes back to a lot of the points that have been made by Syama in the past, looking at your land as well. avoiding those heavy clay soils has helped a lot. You know, you can only bang your head against the wall so many times. So really, to me, I think the biggest thing that I've seen that's helped is rotation, field selection by watching those textures, and fertility management as well. I know peas are good scavengers, but I hate seeing them go down without some level of fertility there, especially phosphate. I think that's a huge one for us. So, you know, it's a roll of the dice. You know, testing, you got to watch for those false negatives. So I think, you know, the points that were brought up before here is growers that are following those are having a little more luck, but we're running out of ground in a lot of places. So we do what we can, and we still can be successful with it. Just have to heed the advice that's been given here.
Thank you. Ivan, I'm going to put sort of the same question to you, and you know, you may have a different approach or some additional thoughts onto what Scott says. Again, you're in that Northwest and that hotspot area as well.
Yeah, it's the same. Field selection would be the one, and as well crop rotation. So like recently we've seen so many yield maps when we lay those maps in 3D mode. So we see like lots of those low areas, for example, low areas with the low yield, yielding areas, and that's what basically it's happening out there. Plus the field selection and also crop rotation, and as well fertility. That's a huge one, yeah. So we often forget, like, you know, peas are good scavengers, and if you look at, for example, at the some removal rates, peas tend to remove lots of potassium, just an example, more than other crops, and phosphorus is a huge one. Already seen some in trials that phosphorus plays a huge role in peas, so that helps out to boost the crop. And the seeding depths, yeah. So we have to consider the seeding depths as well, and I know like seeding deeper sometimes doesn't help. That's where we get the a little bit thinner plant stand, thin a little bit as well. By seeding a little bit shallow, our stem gets a little thicker. As the stem gets a little thicker, then it's actually a little bit less prone to disease, yeah, than a thinner stem, the seeding deeper. But again, it depends what soil conditions in the spring. Yeah, if it's a little bit drier, of course you don't want to seed that shallow, yeah. So.
Awesome, thank you. So adding kind of seeding depth into the mix when we're considering with root rots, how to mitigate them.
Yes, yeah, and it depends. Like this, some different, for example, opener stuff like that. Yeah, if you're seeding like with the paired row system where it's a push the seed on the side, and of course doesn't pack really well, but at least the peas are not sitting in that really moist condition, under cold conditions. Yeah, if we're seeding with just one shank where we pack hard, and that's what happens in like the pea seed sits so much in the wet, cool conditions, and of course, yeah, it more will prone to a root rot. So and yeah, it's kind of like it's more gambling with the soil moisture in the spring, at which seeding depths that you need to seed peas, yeah.
Well, thank you. I think on the root rots, and you guys both mentioned fertility, so let's bring Jeff into this discussion about the thoughts around higher fertility that could help mitigate some of the yield loss associated with root rots. We know roots are important for the uptake of nutrients, and if they are not healthy, do you think that there's things that we can be doing on the fertility side with either higher soil rates closer to the seed or foliar type products that could help with mitigating some of that root rot loss or protect some of the yield potential with the root rots? Oh, you're muted, I think, Jeff.
There we are. No, I'm on. Great. Yeah, no, I think you know, I agree with what Scott and Ivan said, and as I pointed out, you know, a well-nourished crop is a stronger crop. It's going to be able to better fend off pathogens, and that includes root rots and their negative effect on things like water and nutrient uptake. So especially when roots are compromised, that really affects the availability of those nutrients that are less mobile, like phosphorus, in particular. Also perhaps potassium in some instances, although generally we don't see a lot of issues with potassium deficiency affecting the growth of peas or response to K in the year of application, particularly compared to phosphorus. You brought up the topic of foliar phosphorus fertilization, and we've done some work with that and recently published in the Canadian Journal of Plant Science. And what we found is that with the foliar phosphorus, you can get some phosphorus in through the leaves, but there's a limit, and it's not a whole lot. And it really doesn't substitute for having that phosphorus available in the soil at the time of seeding for the roots to take up. It's really more of a top up. We haven't evaluated the foliar phosphorus though under conditions of really severe disease pressure. So in all of our trials, we've generally worked with it under pretty good plant health conditions.
Thank you. Thank you. Moving on to a question for Syama. We're looking at testing for Aphanomyces. When is the best time to do it, fall or spring? And where can you send samples in to get the testing done?
Good question. So in the fall after a pea or lentil crop is the best time to test if you want to know if you have Aphanomyces or not. And that's because you'll still have some roots in the soil and you'll have less likelihood of getting a false negative. The problem is we really want to move towards soil testing in the spring as kind of a pre-plant decision to know if you have a risk or not. So, you know, if you know you have Aphanomyces and you're looking at planting peas in a field, you know, 4 years later, then the idea is you want to go in with that spring testing to inform the knowledge on the risk of the crop. So if you want to know you have Aphanomyces, the best time is in the fall, right after a pea or lentil crop. But if you're using it to make seeding decisions for that field, then the best time is in the spring. But just keeping in mind this issues with false negative. In terms of companies that provide soil testing, I know like Discovery Seed Labs does, I think Quantum Genetics, BDS. There is a number, and I think Sherilyn might know better than myself as well, which companies offer them, and they might even be posted on the Saskatchewan Pulse Growers website. And each company does offer a different kind of test. I think Discovery does soil dating, Quantum Genetics does a DNA test. So I can't list offhand every company that does it, but I think that information is there on the Sask Pulse Growers website.
Thanks, Syama. Yeah, there is actually a fact sheet that outlines the labs that do the testing and what kind of testing they do and where you can send samples. So definitely the audience can check that out for more information on how to take the samples and all that kind of stuff too. I guess on the Aphanomyces side, I'm going to move on to Tom. I'm kind of doing a round table here. I'd like to ask you the question about with pea variety development, where are you at in terms of having varieties that are going to have more resistance to Aphanomyces?
Yeah, thanks for the question. It's a big topic, and it's a project that we've been working on for quite some time, together with Syama, together with Sabina Benitza. So far we've used kind of a molecular breeding approach. So we're trying to bring in resistance from sources that were identified by our colleagues in France and US. We have material that was multiplied in the field in 2020, relatively small amounts. So that will go out in a bigger scale in 21. So really the work so far has mainly been indoor testing together with using marker assisted breeding strategies. So it's still a little ways, but if we see something good this year, we'll hope to put the best material into registration trials next year.
Awesome. Look forward to seeing some of those varieties. So we'll go back to our agronomists, and I'm going to ask a question about seeding rates because I know Shaun talked about seeding rates, and then there'll be a question going to Shaun regarding that. But just seeding rates in peas, what are you seeing out in the field in terms of the seeding rates that growers are using? Are they sticking to the old recommendation of the 85 plants per square meter or seeds per square meter? Or are we starting to see higher rates to help combat the weed, or help with the weed control? I'll ask Ivan the question first.
Yeah, it's growers are using different seeding rates. You know, like it's the old method, like 3 bushels to the acre. So it's but some growers as well, yeah, pushing a little bit higher. So it's like 3.5 and 4. And we can see more growers that start using 1,000 kernel weight. So which just helps them out a little bit to basically be more precise in terms of the seeding rate, because some seeds can be a little bit small, some bigger. For example, green peas tend to have a little bit higher seeding, 1,000 kernel weight versus to the yellow peas, which is a little bit, sometimes can be like, for example, 180 or 200 grams per 1,000 seeds. So, and again, so it depends on your field and depends on the spacing as well. Yeah. So for example, on 10-inch spacing, you could push a little bit higher seeding rate. On a 12 or 13, 14-inch spacing, of course, yeah, it might be so many plants in a row, which will tend to have more lodging. And as you go a little bit wider in spacing, so peas tends to, for example, to try to catch to each other. Once to catch to each other, they tend to go a little bit and go down. Yeah. So, but again, typical 3 bushel rate, but 3.5 to 4 bushels. I see some guys been going, and I've done some a little bit trials just few years ago, and when we seeded 2.5 bushel, 3 bushel, 3.5, and 4 bushel, and 3.5 bushel seems to me out yielded our 4 bushel and lower 3 or 2.5 bushel rates. Yeah. So.
Thank you. Scott, do you have any further comments on that question?
You know, from what I've seen, and to Ivan's point, 1,000 kernel weight, we've really been looking at that a lot more heavily, but I'd say 8 to 9 plants per square foot is kind of where we've targeted for peas. You have to look at everything as a bit of a double-edged sword. The higher seeding rates, the denser the canopy, you're going to also perhaps use more moisture, but to Ivan's point, your lodging will increase. I mean, peas are not inherently that competitive of a plant. It's not that they're quite leafy either. So, I mean, while it might have some effect in theory, honestly, we've kind of been sticking to the tried and true, and I think it's worked fairly well. The other thing I look at is for disease concerns, and potential increased canopy also slows the dry out of the soil. So, anyways, it's hasn't changed a lot. I'll put it that way from what I'm seeing.
Okay.
And again, sorry, it depends as well, like how high you cut your, stubble. If you have some stubble and seed between the row, between the stubbles, that would help to for better standability. Yeah.
Okay. So Shaun, you had mentioned targeting rates of maybe up to 120 plants per square meter. What would you say would be sort of the suggested seeding rate for that in potentially pounds per acre? And do you have an idea of what the estimated mortality rate would be?
I'm not as comfortable with that off the top of my head, so I may have to get back to you on that.
Okay, not a problem. I'm going to ask Tom then, with seed size and 1,000 kernel weight coming into an impact with calculating seeding rates, but also the comment that larger seeds can be more competitive. Is there anything in the breeding program that you're looking for in terms of increased competitiveness to help with weed management or seed size?
We don't usually think of it so much from a seed size point of view, but I think going back to work from Steve Shirtliff more than a decade ago, we tend to find that taller plants tend to be more competitive with weeds. That seems to be the factor that is the most related in that way, and it probably deals with shading and those kind of aspects. So I think you've probably seen that pea varieties are probably a little bit taller than they were maybe a decade ago. And I think it's not totally on purpose. It's sort of an indirect way. As we select for higher yield, we're probably selecting ones that tend to be a little later maturing, a little taller, and you sort of get that kind of a package. So pea is already a kind of early maturing crop. So in my opinion, I don't mind if we go a couple of days later, if it can give us more yield and more competitiveness.
Okay.
I don't know, maybe the agronomist might disagree with that, but I just throw that out there.
Good question. Let's ask the agronomist.
So
Well, I think, you know, to your point there, Tom, anytime you stretch out maturity, you tend to bring along yield with it, right? I mean, that's kind of inherent within a lot of plant breeding and goes to many crops. So, and I mean, peas, they're not late anyways for our geography. So, I mean, it's not as big of an issue, but I agree on the height. I think, you know, anything that gives more shading, it's going to be more competitive. So, I mean, I couldn't believe it. I'm a relatively tall fella, and when I was in a pea crop a few years ago up by Cut Knife here, I mean, it was up to my chest. And I mean, that's probably a 5-foot tall pea crop, which scared the bejeebers out of me, but the guy was able to harvest it still. So, and I think to the question on seeding rates, I mean, to give a hard number is a really tough one, Shaun, right? Because seed lots differ in 1,000 kernel weight, in germination, what disease levels are you seeing, what are the conditions in the field, that all goes into your survivability. So it's kind of a hard one to say without knowing what you're dealing with first, but you can get up into seeding rates in that 240 plus pounds per acre. I mean, that's an eye opener for some folks.
So only one thing I want to just add it in, Wentz. Of course, if you want to leave some for seeds, then of course you may have to cut your seeding rate. Then at least you have a little bit more and bigger kernels. If you actually push in your high seeding rate, your kernels might tend to be smaller. Your 1,000 kernel weight could be like, you know, a little bit smaller. So that's why if you leave, for example, 100 acres or something like that, you're probably better off to cut your seeding rate a little bit. Yeah.
Thank you. Thanks for the discussion. So we'll shift gears just a little bit, and we're going to go back to talking about residual herbicide products. So put the question to Shaun. What is the realistic expectation for growers when they're moving to using those residual type products? You know, we've used a lot of in-crop herbicides, and you know, you always expect that 95 to 100% control. What's realistically, what should we be expecting with some of these residual products that are having activity in those germinating seeds?
Right. With edge or ethafluralin, it's going to depend on which weeds you're targeting. But if you want to use it for wild oat control, you probably get less than 80%, and you want to complement that with pre-seeding or pre-emergence applications of glyphosate. With the PPOs or Group 14 herbicides, assuming the environmentals are favorable, so you're getting enough moisture to activate them and they're available to control the weeds, you should get good control, probably greater than 90%, but I think it's that activation by moisture that's going to be a huge limit, I think. And from what I've been hearing from producers and agronomists, that's where concerns are, is that there's just not enough moisture early season when they need it and weeds are escaping, and then now you have weeds in your crop and you already put down a herbicide. So if conditions are favorable, I think they will provide excellent control, probably close to 90%, and that's going to extend into the crop until that crop can establish, and then you will be relying on your crop to help control the weeds after that. So it's not a huge window. It's not going to take you half the summer. You know, it may be 3 or 4 weeks, depending on the chemistry. But yeah.
Okay, thank you. That makes sense. So let's see what the agronomists have been doing for residual weed control and how that's been working. So Scott and Ivan, if you have some comments on the weed control aspects that you're seeing working well in peas, and maybe a bit on the timing of when guys are using the residual products and what combinations. I know that's a big question, but if you can just provide us kind of the highlights of what you really like moving forward with peas. Ivan, do you want to go first?
Yeah, it's a few different products and depends on your weed pressure and weed situation. So yeah, it's for example, yeah, it's typically be glyphosate for pre-burn, and it's been used AIM or heat, for example. It depends again on your weed pressure and the conditions. So edge or some, for example, some of residual product like Authority. So, but typically it's more be Gold Wing, glyphosate or heat, yeah, as a pre-burn.
Okay. So more of the tank mixes in the pre-burn.
More the tank mixes. It's typical and depends again what conditions are in the spring. Sometimes we just go out and it looks like we don't see any weeds once we go seed it, or after seeding all the weeds are popping out. So and heat, and my past experience, heat has been working really well, and especially under cooler conditions. I don't know why, but for some reason, yeah, we've sprayed some heat under cooler conditions, and we sprayed the after seeding when the conditions, like temperature conditions, were a little bit warmer. But seems to me that heat has been working really well under cooler conditions. Yeah.
Okay.
It gives that a little window before the crop is up. And for example, especially for volunteer canola or for wild buckwheat, yeah.
Okay. Scott, do you have some further comments on your thoughts on this and what you're seeing?
Oh, totally agree with Ivan. Love seeing the tank mixes, and that is getting better. We're seeing a lot less straight glyphosate going out, which is a very good thing for us. You know, I'm a big fan of the pre-emergents. I mean, I'm not loyal to any one brand really, but I mean they all can work very well if you use them where you need them. You know, if kochia is your target weed, then you've got your options for you know, your group 14s or even your 3s can have some activity there, right? But the biggest thing, I think, to Ivan's point, is the burn off. Just because you've used one of these soil residual products, go for a walk. If you don't think there's weeds out there, walk in your field. You'll find weeds. The 60-mile-an-hour crop check, which I may or may not have done once in my life, you're not going to see as much as when you actually get out there and even get down on your hands and knees and look, and you will see all sorts of lovely little weeds coming up in your field. So scouting is huge, and I think, you know, with agronomists and with growers taking closer stock of the farm, we're seeing a lot more intensive scouting, and practices have definitely been going the right direction for weed control, for sure.
Great. It's nice to have some products that now registered for our use in peas as well. There's quite a selection, which is kind of nice, whether it's pre-seed or you know, even a couple in crops. So
it's come quite a long ways.
Yeah. Last question, because we have literally 1 minute left. I'm going to ask Jeff if you would like to comment on the impact of fertility on protein levels in peas.
Yeah, I guess in terms of impact of fertility on protein, it seems that the major driving factor is probably the environmental conditions and the yield, as it maybe influences the nitrogen fixation, as it influences protein production, nitrogen and protein production in the plant. I think that fertilization, we found in our work, and I think we did it, I'm trying to recall, we did it with peas and soybeans, nitrogen fertilization really didn't bring the protein content up. So we're starting some work now with Tom to take a look and see what other influences might be there. Micronutrients like molybdenum, for example, just to explore some of the possibilities. But I don't think in terms of fertilization and protein that there's going to be any really big impact factor. Phosphorus, in as much as it promotes the nitrogen fixation, can help. But unlike cereals where you can pour the nitrogen to it and bring the protein up, that really isn't the case with the pulses like peas.
Thanks, Jeff. With that, I think we're ending our question and answer session, and we by no means covered every question that came in. I want to thank everybody for all the questions, and we will try to get some answers out to you in a document following the presentations here in the following days. So with that, I just want to say thank you to everybody that participated in the question and answer, and I'm going to turn it over to Shaun.
Okay, thanks again, Sherilyn and Scott, Ivan, and all the rest of the presenters today for putting on a great program dedicated to peas. That wraps up today's session. Thank you again to Schooler Canada for sponsoring today.